For the first system that we're going to compare to the one we have now, we have what is called the Babylonian System, which dates to thousands of years BCE, as the Babylonian Empire lasted between the 19th and 15th centuries BCE in Mesopotamia, which is today Iraq, where their system is built, instead of being around powers of 10, it is built around powers of 60. And the accepted explanation for that is a bit of a peanut butter and chocolate one.
What?
Where some traders in the region worked on fives. I'm guessing, but don't actually know. They probably liked one hand. On the other hand, a different group of traders liked using a system based 12. And rather than fighting endlessly over which system happened to be the best, they reached a compromise. Compromise not quite as much fun as the Reese's Peanut Butter Cup.
Delicious.
Two great tastes that taste great together. Reese's Peanut Butter Cups. Real milk chocolate, delicious peanut butter.
But still a very nice one in terms of peace in the region. They built their system around base 60, as they wanted both 5 and 12. Multiply those, you get 60, where their system, being built in that way, has digits that go all the way up to 59, but does not have a digit specifically referring to 0. Babylonians did understand nothingness, but didn't consider it to be something worthy of that specific mathematical counting representation in the way that we have it in our system and the way that it exists in others. Where, for what we're going to use, instead of having this complex one, we're going to use a more simplified version here, where we have that symbol that looks a bit like a V for ones for single values, and the one that's sideways looks a bit like, I guess that would be a less than, a little caret, for tens, where again we can go up to 60s, and like our system, as these groupings move left, we're talking about greater powers of 60, which again, it's going to look a little bit weird just seeing it initially, but once you actually get an example for how this sort of thing can be translated to our system, hopefully it'll make a bit more sense. So for this example, we want to express the digits written below, which I should have looked up the name of, but I don't know offhand, as a Hindu Arabic numeral. Well, nice thing about not having zeros, other than the way it makes a mess of working with reciprocals, is that we don't have to worry about any hidden groupings in between there. We don't have to worry about any values that correspond to another digit, like what we had with the Hindu Arabic system. We just have those three groupings there, where, because the biggest are on the left, we can take that and start translating it, where we know that on the far left, because that is the third one over, we have that describing 60 squared terms, where we have two terms, they're both ones, so we have 1 plus 1, 60 squareds. Then in the second, we have that 10 symbol plus a 1 symbol, and that is the 60 to the first digit. And then in the third, we have two 10s and two 1s, where that is the 60 to the first, or 60 to the 0th power digit. So again, because we have three groupings, if we want to start from the right instead, the rightmost is always the ones place, it's always the single values. Then we go up to a single amount of our compromise, 60s. Then in our third, we get to 60 squareds, and if there was a fourth grouping, then we'd have 60 cubes, and so on. But nicely, because we don't have zeros to worry about, we know that we just have that 3. Where from there, if we want to put all this together, get our actual Hindu Arabic number, the number that we can understand instead of these, well, angles, I guess you'd almost call them, we would have 2 times 3600 plus 11 times 60 plus 22 times 1, or 7,882. So again, the main thing to understand when you're looking at any numeral system is, for one, what we're dealing with as a base, what we're building our groups around. Then two, what sort of language our symbols are in. Then, well, hidden in there is whether or not we have to deal with a zero, as well as whether or not our groupings are ordered left, right, right, left, up, down, as we'll see later as well, and then translating them in terms of how those pieces come together to get a symbol that we understand a little bit better. And the last thing we're going to look at for this section is one more numeral system where that one has its own features, and for this, we're going to be looking at the Mayan numerals.